Hello everyone, welcome to Pepcoding. In this video, we will look at the question where will the ball fall? Okay, so let's see. In this question, we are given a grid like this. Okay, we are given a grid like this, and it is open from the top and it is open from the bottom, right? And it has boundaries on the left and the right. Okay, so in this grid, there are some cells, right? There are cells like these, and in every cell, there are some boards. So you have a board like this, and 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 a board like this. Okay, so let's say I have a cell like this, right? I can have a board like this, right? Or if I have a cell like this, then I can have a board like this. Okay, now it is saying that there are some balls, right? There are some balls given, and that ball can fall right onto the grid. And as the ball falls, it encounters the boards, right? And on the basis of the boards, it decides where it wants to go. So if it lands on this board, it goes on the right, right? If it lands on this board again, it goes on the right. If it lands on this board, it goes on the left, right? So it means that if a ball falls on this type of board, if it falls on this board, it goes on the right hand side. If it falls on this board, it goes on the left hand side. Okay, so this is what the ball will do on the basis of what board it encountered, right? So we have to find the column out of which the balls are going to come out, right? So let's see. Let's take the column's answer, right? We have a vector of answer, right? This will store my columns, right? This is for my columns, and I will have ball 1, ball 2, ball 3, ball 4, right? Ball 0, ball 1, ball 2, ball 3, ball 4. So I have 5 balls, and every single ball will try to come out of the maze, right? This maze or this grid. Okay, so let's see. Since this is the ball 0, and it falls here, right? It falls here, and then it encounters a board like this, so it goes on the right hand side, and it falls again, right? It goes on the right hand side, it falls again, right? It encounters a board like this, goes on the left, falls again, right? Encounters a board like this, goes on the right, falls again, right? Goes on the left, falls again. So it comes out from my first column. So the zeroth ball came out from the grid at the first column. So I'm going to store 1 here. Okay, that this ball came out from the first column. Let's see for first ball or ball 1. Okay, this ball 1 goes down, right? Then it goes on the right. Then or we can say falls down, goes on the right, falls down, goes on the right. Now it encounters a board which is like this. So if you have two boards like this, let's say if you have two boards like this, right? And if you put a ball like this, then it is going to go on the right, right? Then if it encounters this board, then it is going to go on the left. It's going to go on the right, going to go on the left, so it will be stuck here, right? My ball is going to be stuck here, so it is never going to come out. The ball is going to be stuck in this case, right? So it is never going to fall out. So I will put -1 for ball 1, right? Because it is never going to come out of my maze. Similarly, for my second ball or ball 2, it is going to go on it is going to fall, going to go on the right, going to be stuck. I'll put -1. Similarly, ball 3, going to go down, left, right, stuck, -1. Ball 4, down, left, down, left, stuck, -1. Right? So I will return this vector with 1 for my ball 0 that it came out from my first column, and the rest of them were stuck in the column itself, in the maze itself. Okay, so this is how we are going to solve the question. This is my brute force approach, what we are actually trying to do. Now, how are these maze actually represented in the, like, how are these boards actually represented in the grid? We don't have boards like these. Okay, so we are representing a board like this by 1 and a board like this by -1. Okay, so this one is representing a board of type this, and this -1 is representing a board of type this. Okay, so instead of having a board like this, we actually have something which resembles like this. Right, we have 1 1 1 -1 -1 1 1 1 -1 -1 and so on. Right, we have something like this, and for the case of ones we have boards which are like this, and for the case of -1 we have boards which are like this. Right, so the ball will decide to fall like this. Right, it will decide its path on the basis of what type of board it encounters. Okay, so if it goes like this, it's going to stuck in between. If it goes like this, now it's stuck in between, and so on. Right, so this is how it is actually represented. So I hope you understand the question at least. Now we are going to solve this question using the brute force manner. Right, what we'll actually do, let's see this using code. Right, we'll code as we explain how we are actually working. So first we will need my grid size. Right, I'll need my rows and columns. Now I will make a vector answer, right, of m size, because I'm talking about the columns, right, and I'll return this answer after doing some work. Right, now what is the work? I will start from 0. My j will start from 0, because I'm talking about the balls, right? So the balls are representing, or the balls will be only working in the columns. So I'll put this loop for my columns. Right, now I will have two things. I will need two things. I will need a current position and a next position. Okay, so if I have one in this grid, right? If I have a one here, right? If I add this one to my current position, if I add this one to my current position, isn't it going to go on the right hand side? Right? This one, or this current position, will go on the right hand side, right? Because, right, if I take this one and if I add this to my columns, let's say I'm talking about the columns here, and if I add this to my column, it is going to go on the right, right? If I have j plus plus, or I can write j minus minus, right, to go on the right or to go on the left. But instead of doing that, can I not just add this one to my column, and it will do the same thing, right? So I can traverse on the right hand side or on the left hand side on the basis of the value which is here, right? So if I have a 1 here, I'll just add it to my column, right? If I have a -1, I'll add it to my column. And if I add -1 to my column, it is going to go on the left. If I add, right, we have -1 here, so it is going to go on the left. If I have 1 here, it's going to go on the right. Okay, now we also see that the ball is always falling, right? No matter what the board is, the ball will always fall. The ball will always fall. It will change its direction based on the basis of the board it encounters, right? So we need to see that the ball will always fall. The ball will always fall, but the board, right, the board will decide on which direction it is going to go. Okay, so here we will first take our current position and our next position. So current position will be j, and my next position will be -1. Let's initialize them like this. Now for int I equals 0, I is less than n, and plus plus I. Right? It means that my ball will always fall. If my ball will always fall, then my next position will be current position plus grade of I plus grade of I in current position. Right? So I'm adding the 1 and the -1 to my current position to make it my next position, right? If I add 1 to my current position, it is going to go on the right. If I add -1 to my current position, it is going to go on the left, right? So if I add 1, it is going to go on the right. If I add -1, it is going to go on the left, right? Now let's talk about the edge cases, right? If I have a case like this, right, if the ball falls here, it is going to go in between this, it is going to be stuck in this loop, right? It is going to be stuck here. The ball will be stuck here. If I have this board, right, if I encounter this board, it is going to be stuck here, right? Similarly, if I encounter this board, it is also going to be stuck here. And what is the third case? That if I encounter something like this, right? If I encounter something like this, the ball will also be stuck. And what is this? What is this case? This case is when my current value, my current position, or my current grid value is not equal to the next position grid value, right? If it was one, if for this case, let's say I have 1 and 1, right? So the ball can freely go. But if we have 1 and -1, then we would have boards like this, 1 and then -1, a board like this. So it is going to be stuck in between, right? So for that case, for these three cases, that if my next position is less than 0, or if my next position is greater than equals to m, or if the grid of I, comma, or I of C position, current position, is not equals to grid of I of next position, right? If this is not the case, or if this is the case, then it means that my ball will be stuck. So I'll make my current position as -1 and I'll break from this loop, right? Else it means that my ball is falling normally. So I'll update my current position with my next position, right? And after this, my current position will come out from the right column. So I'll just store it in my answer of J, right? So this is my code. I hope you understand the approach. Let's try to run this. Okay, there was some issue. Let's run this code. It is successful. Let's submit this. It is also successful. So I hope you understand this question. If you don't, I would suggest rewatching the part which you don't understand. Don't forget to like, share, and subscribe. Thank you for watching.